Today, I would like to introduce you to Einstein Vision, a groundbreaking project revolutionizing autonomous driving technology. Our pioneer work in 3D traffic visualization is creating a foundation for safer autonomy on our roads. In our pitch video, you will witness the remarkable potential of Einstein Vision technology. We transform complex traffic environments into precise visual data that autonomous vehicles can interpret instantly, enabling them to navigate urban settings with unpretended accuracy and safety. As Manideep Duggi, I am proud to be working alongside my colleague Pavan Ganesh Pabbineedi on Einstein Vision. We are both pursuing on Masters in Robotics at Worcester Polytechnic Institute, bringing together our complementary skills in robotics and computer vision to create this breakthrough technology. We invite you to watch our demonstration and imagine the possibilities of truly safety autonomous transportation. Thank you for your attention to Einstein Vision, a safer autonomy.
Einstein Vision, an easier autonomy. A near miss that changed everything. In that split second between safety and tragedy, when a pedestrian steps into a crosswalk barely visible in the darkness, what if your vehicle could see what you can't? What if it could understand the road with even greater perception than Tesla's autonomous systems? That heart-stopping moment of a near miss isn't just frightening. It's the catalyst that inspired Einstein Vision, our revolutionary perception system that transforms how humans and machines communicate on the road. Introduction: Bridging Human and Machine Perception. Today, we're thrilled to introduce Einstein Vision, a comprehensive visualization system that doesn't just see the world, but truly understands it. Inspired by Tesla's dashboard visualization, but taken to the next level, our system creates an intuitive bridge between human intuition, machine precision, and safety. Core detection capabilities. Einstein Vision processes far more than just basic objects. Lane detection and classification. Using advanced mask RCNN technology, our system precisely detects and classifies lane markings, distinguishing between solid and dashed lines, even in challenging lighting conditions. We extract 10 equidistant points along each lane using second-order polynomial fitting, creating a robust representation of road structure. Vehicle detection and classification. Our implementation of YOLO V8X provides robust detection and classification of all vehicle types: cars, trucks, motorcycles, and bicycles, with exceptional accuracy. Traffic light recognition. The system recognizes traffic light states and directional arrows, providing critical information for navigating complex intersections. We've implemented temporal consistency checks that track traffic lights across consecutive frames, using a voting mechanism to determine the most likely state and reduce flickering. Road sign detection. Road signs and markings are instantly identified, from speed limits to stop signs, ensuring awareness of all traffic regulations. Our system places particular emphasis on stop sign detection, as specified in the project requirements. Advanced perception features. Enhanced vehicle classification. Beyond basic detection, our system implements granular vehicle classification that distinguishes between sedans, SUVs, hatchbacks, pickup trucks, and other vehicle types with over 90% accuracy. We analyze the aspect ratio and orientation of bounding boxes to determine vehicle orientation. Pedestrian pose estimation. Our system implements full-body pedestrian pose estimation through a two-stage process. First, we apply a YOLO V8 pose estimation model to detect people and extract body key points. Then, we estimate depth to convert these key points into 3D world coordinates, understanding not just where people are, but how they're moving. Road marking detection. We've implemented sophisticated road marking detection for directional arrows, lane indicators, pedestrian crossings, and speed limit markings using a custom-trained mask RCNN model. This creates a comprehensive understanding of road instructions. Safety obstacle detection. Safety obstacles like cones, poles, and cylinders are instantly identified, ensuring awareness of temporary road hazards and construction zones. Even roadside elements like dustbins are detected, creating a comprehensive understanding of the urban environment. Cognitive abilities. Brake light and indicator detection. Our system detects brake lights and turn signals on other vehicles through a multi-stage pipeline. First, vehicles are detected. Then the system determines if they're showing a rear view, identifies tail light regions, and analyzes brightness levels and color presence to determine if lights are on or off. This anticipates vehicle intentions before they make their moves. Parked versus moving vehicle classification. The system distinguishes between parked and moving vehicles through sophisticated optical flow analysis using the Raft neural network. We estimate ego motion using homography-based flow and subtract it to isolate vehicle-specific motion, providing crucial context for predicting traffic patterns. Speed bump detection. Einstein Vision even detects speed bumps before you feel them, allowing for smoother navigation and increased comfort. We trained a custom YOLOV 8X model to recognize the distinctive visual patterns of speed bumps. Collision prediction. Our collision warning system calculates precise distances to surrounding objects using our depth estimation pipeline and provides early alerts to potential hazards when objects are detected within a critical distance threshold, giving drivers precious seconds to react. Technical approach. Behind this intuitive interface lies sophisticated engineering combining traditional computer vision with cutting-edge deep learning. Depth estimation. We employ Intel's DPT hybrid MIDAS model to estimate relative depth from a single RGB frame, converting raw depth output to metric depth using an empirically derived formula. This transforms flat images into rich 3D understanding, allowing precise spatial positioning of all detected elements. 3D projection. The system seamlessly converts 2D detections into accurate 3D world coordinates using perspective projection with camera intrinsics, creating an intuitive visualization that mirrors human perception. Blender visualization. Everything is rendered in Blender through a custom Python script that imports detection results from structured JSON files and creates corresponding 3D objects for each detected element, animating them over time to create a smooth and continuous visualization. Conclusion. We stand at a critical inflection point in the relationship between humans and autonomous machines. In a world where machines make life or death decisions in milliseconds, understanding can't be an afterthought. It must be built in from the beginning. We're making the invisible visible, building trust through visualization, one perception at a time.
In our project, we mainly tackled three major technical hurdles. Firstly, we developed adaptive thresholding technique to ensure accurate detection over both bright daylight and night scenarios. And secondly, multi-source 3D data integration system. And third, we combined hybrid learning approaches with geometrical approaches to achieve precise depth estimation. And fourth, motion analysis algorithm. Fifth, we created a dynamic light rendering system for the indicators and taillights. So it can intelligently scale our vehicle lights based on the size and distance they are visualized. And finally, large-scale batch rendering. So we did an automated batch rendering for thousands of frames within the Blender. So these solutions collectively enabled our system to create an high accurate 3D representation of traffic scenarios. Our system delivers four key impacts: enhancing driver safety by improving awareness and reducing accidental risk, and supporting both the current and the future autonomous platforms, providing real-time feedback for better driver education, and offering researchers and academics a robust platform for testing and developing advanced autonomous technologies. Our heartfelt thanks to our professor and the instructors for the special guidance and support, and special thanks to all the classmates and friends.